Okay, so today we're going to go over the repeated use of integration by parts. And here we have an example. It says to evaluate the integral of e to the x times the cosine of x with respect to x. So you may be thinking it's like some of the other problems we did in our last lesson where we're using integration by parts more than once. That's a little bit of what we're doing here, but it's slightly different, okay? So we're going to take a look at how to do this problem, and you'll understand why it's under its own lesson and its own title of repeated use of integration by parts. Here we go. So for this problem, we want to keep u as our exponential function and dv as our trig function. It's typically the case, okay, right, with respect to x, such that, next step, write du is e to the x dx, and over here, if we integrate both sides, we get v is equal to the sine of x, okay? And then we can apply our formula. But now, when I'm applying my formula, I want to include that I'm evaluating this integral. So I kind of want it as part of my work. This will equal uv minus the integral of v du. I have parentheses here. Okay. And so with that being said, okay, we need another integration by parts for this expression here, okay? So we can't just break this down and it's an easy integrand. We can easily find the antiderivative. Okay, we need u substitution. So once again, you may be thinking, hey, this we've done yesterday. Keep u as e to the x, and this time dv would be sine of x dx. Du is e to the x dx, and v equals the negative cosine of x. All right, so now at this point, okay, we already have this expression here, okay? But we want to keep that it equals our answer. So, I'm going to start rewriting this. The integral of e to the x cosine of x dx equals e to the x sine of x minus, here we go, our new uv, so it's going to be negative e to the x cosine of x, because you're multiplying by a negative. And we're going to say plus, because we're supposed to subtract, but we're integrating v, and that was negative, du. Okay, let me close my parentheses, such that you are aware we just substituted that integral with this whole expression, and before that it was negative, so we want to make sure that we show that subtraction beforehand. But what we also want to see is that we have this expression here, okay? It's the same as our example, or I should say our what we need to evaluate, our problem. It's the same as our problem. Okay, same thing. So, with this equation, all right, let's actually distribute that minus sign for a second. It may be simple enough for you to follow along, that you don't need to have that there, but just want to be consistent. I can add this over to the other side of my equation because I'm saying that it's equal. I'm actually making it an equation. So with that being said, You're probably wondering, with that being said, she ran out of space to finish this problem. So I'm going to have to erase what we have at the top here and rewrite it. Hold on. Okay. So this would give me 2 of the same integral. And it'll equal e to the x sine of x plus e to the x cosine of x. Okay, and remember we added it over so that becomes 0. And so if I need to evaluate the original problem, I'm dividing by 2 on both sides. And this is an example of the repeated use of integration by parts. Not only did I need to use integration by parts twice, I ended up with an expression that was exactly like the original problem. So I needed to divide by 2 in order to evaluate it. Don't forget to write plus c if it's an indefinite integral, like we do have in our problem. And we're done.